one of the persistent questions that I keep running into as I'm doing this is that I need a battle system that works in concert with the training mechanism. So the training mechanism is the ability to combine cards together to be able to create an action, and the combat system is a turn-based role-playing combat system. And what I need to be able to do is produce a clear way that the actions in the combat system can be derived or produced from the training mechanism, which is a combination of various component cards. And this works very well on paper, but is very complicated to do in a software setting like Unity. So what I've come up with is an idea that basically we need a kind of queuing system for actions. So at first I was thinking of it in terms of the action has certain kinds of properties. It has the ability to declare a certain action type. Then it sets a target, and then it rolls to succeed, and then it deals damage, and then it applies an effect. This would be an example of, let's say, like a fireball, where we declare that it is a power action, and that we declare the target an enemy. Then we roll to succeed against that enemy's defense, their power defense with our power attack. Then we deal the damage, and then we apply a burn condition. But the issue is that this is a standard action in a regular game. It is not component-oriented in a way that allows me to interrupt the process or to structure it so we can swap out things like certain types of effects or damage or what have you when we construct the cards differently. We have to remember that the system that I'm trying to build is basically percolating up from this wide array of cards and arriving at an action. And then the actions themselves interact with the others. And this became incredibly complicated for me to wrap my head around. So here's my solution. Basically, I'm going to treat it like a queuing system. So let's say, for the sake of argument, that declare action, set target, roll to succeed, deal damage, and apply effect. These elements are effectively all the same element. They just have a different kind of operation. So if that's true, then the operation is just effectively some kind of in-game effect. The effect of setting a new target, the effect of, or the operation of trying to roll to succeed, the operation of setting a target, the operation of dealing damage, the operation of applying an effect. And if this is the case, then all I need to do is structure it like a queuing program with a bunch of different operations that are attended to the cards. So if I declare this action and the opponent wants to declare a opportunity action where they clash against it, then obviously I declare the action and then I set the target. And in the moment that that target is set, with the action type being a power, that person will be prompted with the ability to declare an opportunity action. And so I need to have like a manager running behind the scenes that says, oh, there's an opportunity that's happening right here. And so now what I need to do is ask that person if they want to interject. And if they do, then I'm just going to take this and I'll move it to the back, and then I'll grab these elements. Hold on a minute here, create a little space. Create these elements and then inject them into the queue. And so now the declare action set target declares the opportunity. So it clears this, and now it injects all this at the beginning. So we now have the opportunity is declared. We force both to roll. Then we have two conditions. If the opportunity character succeeds, then we ignore everything that follows. If the opportunity fails, however, then we simply continue to the roll to succeed and deal damage, and then we apply the effect. And so this approach has enabled me to start looking at actions in terms of its component base. So if I look at, like, for instance, strike, there are a set number of elements that are effectively in every single operation. So we have a condition, we have a cost, we have a method, we have potentially a persistent element, some sort of secondary thing that we're attaching here, a target, and a magnitude. So in the case of our strike, the method is damage, there's no condition or cost, there's no persistent element, the target is the target's HP. I know it says target's HP. In this case, we set a parent target, like a global target, like the enemy, which is specified in a different operation. Like an operation of set target would set a specific global target. Then the target's hit points is a more refined form of target. And then we go in and deal intensity, which is the magnitude of the damage. And then, of course, we can proceed with other types of effects that follow this. And so I've been able to go through and structure each of the actions around this effect operation approach, where we're basically compartmentalizing certain things. And in the case of techniques, which I have yet to convert, we're going to be substituting certain things. So a technique modifies an action. An example would be like lunge. Before rolling your attack, double the linked action's reach, and you are distracted until your end of your next turn. What this does is, if it's applied to a strike action, then before you're rolling the attack, you're doubling the reach because you're lunging. But the distracted condition effectively makes you more vulnerable. You can't perform more opportunities before your next turn. This is a condition that persists until your next turn. And so these are ways to modify the existing action of a strike. So now I have a means of saying we need to substitute the linked action's reach. And so find the thing that sets the reach, substitute it with a doubling of that reach, and then we look at the very end, we attach a new operation called applied distraction to the user, the person who performs the strike. So now it's very clear how it's happening in code. It's also really clear what components are required for each type. And so now I've got a means by which to structure the whole thing.